Question 10, C1 mock exam 2017. A curve has the equation of that. The points P and Q lie on that and have x coordinates 1 and 2 respectively. Show that the length of PQ is 170, the root of 170. Okay, so before we can even get to this part, we need to first rewrite that f of x into a workable equation. So x squared times x gives us x to the power of 3 because we add the indices. X squared times minus 6 is minus 6x squared. And for the purpose of this, I'm just going to leave the x at the bottom of the fraction for now. Okay, so then I know that one of the points is a 1. So I'm going to substitute a 1 in the place of all the x's. So 1, 3. Minus 6, 1 squared plus 4 over 1. Right, then 1 cubed is 1. 1 squared is 1 times 6 is minus 6 plus 4. And 1 minus 6 is minus 5 plus 4 is negative 1. So our first set of coordinates is if x is 1, then y would be negative 1. Now we still need to work out if x is 2 because that is what they've given us, right? So if x is 2, then we're going to get 2 to the power of 3 minus 6, 2 squared plus 4 over 2. 2 cubed is 8, 2 times 2 times 2, minus 2 times 2, 2 times 2 is 4, times 6 is negative 24, and 4 divided by 2 is 2. 8 minus 24 is minus 16, plus 2 gives us negative 14. So that is our second coordinate point. Right, and now we can use that information to find the length of PQ. Pythagoras taught us that if we take PQ, it will be equal to x1, x2, y1, y2. It will be equal to x2 minus x1 squared plus y squared minus y1 squared. Thank you, the old guy Pythagoras. Right, then we substitute x squared is 2 minus x1 is 1 squared plus y2 is negative 14 minus y1 is negative 1 squared. Right, now please be careful. There's a lot of negative signs here. There's a lot of brackets. Rather take it step by step than rushing it and make a mistake with your signs. So 2 minus 1 is 1 squared plus, keep the bracket for now, negative 14, 1 times 1 gives you plus 1 squared. Right, we've got 1 squared is 1 plus, inside the bracket we've got minus 14 plus 1 is negative 13 squared. If we square that, we get 169, which gives us 170. And that means that if we want to get the value of PQ, we need to take the square root of that. Right, so that is where PQ is 170 squared. Okay. Second part of the question, show that the tangents to C and P at P and Q are parallel. The only words that is really important for you at this stage is tangents, because then you know you need to find the derivative, and P and Q are parallel, so the gradients need to be exactly the same. So again, we are going to start by rewriting our original equation into a workable equation. So f of x is going to be x to the power of 3 minus 6x squared plus 4x. And now I'm taking that x from the denominator into the numerator, and it becomes a negative 1. So if I'm going to find the derivative of this, I'm going to say 3 times 1 is 3x, and then I subtract a 1 from that, which gives me a 2. Minus 6 times 2 is 12x, and that 2 minus 1 is a 1. Negative 1 times 4 is negative 4x, minus 1 is minus 2. And now we are going to use the x coordinates 1 and 2 to find the gradient, right? Because this is the little formula for the gradient for that tangent, right? And if we want to find if they are parallel, they need to be the same. So if I substitute that 1 into this place, I'm going to get 3, 1 squared minus 12, 1 minus 4, 1, negative 2. Right, we rewrite that. 1 squared is 1 times 3 is 3. Minus 12 times 1 is negative 12. And on this side we have the 1 just goes down into the denominator, and anything over 1 is just 1. So it is negative 4. So 3 minus 12 is minus 9. Minus 4 is minus 13. So that's our first gradient. This is our gradient of point P, right? Our gradient of point P. Now we substitute the same, or not the same, the second set of 2 into the same equation. So f, the derivative of f of 2 will be 2 squared minus 12 times 2 minus 4 to negative 2. Okay, 2 to the power of 2 is 4 times 3 is 12 minus 12 times 2 is negative 24 minus, and be very careful here, that negative only applies to the 2, so it basically means this, and 4 divided by 4 is 1, so 12 minus 24 minus 1. 12 minus 24 is negative 12, minus 1 gives you negative 13. And because that gradient and that gradient is the same, it means that the lines will in fact be parallel to one another. Okay. For the third part of this question, find an equation to the normal to C at P, given your answer in the form ax plus by plus c, where a, b, and c are integers. So you need to know that the normal will be perpendicular to these lines. Okay, so your gradient of the tangent was negative 13, right? Negative 13. So the gradient of your normal should be 1 over 13. Because remember, m1 times m2 needs to give you negative 1. So minus 13 times 1 over 13 will give you negative 1. So the gradient of the normal needs to be 1 over 13. Right. So if we need to find an equation for that, so let's just start by saying that y is equal to mx plus c. We can just later rewrite it in that formula. Y is equal to mx plus c, and now we know that m is 1 over 13x plus c, right? We have our set of coordinate points, which we worked out in the first question, of 1 and negative 1. So if we just use 1 and negative 1 and we substitute that set of coordinate points in here, we should get the value of c. If y is negative 1, 1 over 13 is our gradient, x is 1, we should get the value of c. Negative 1 is equal to 1 over 13, because 1 over 13 times 1 is just that, plus c, and then this one comes to this side. Right, and now we have a value for c, which is, if we work it out on the calculator, negative 1 minus 1 over 13 gives us minus 14 over 13 is equal to c. So in that instance, y is equal to 1 over 13, 1 over 13, x negative 14 over 13. But this is not the form in which they wanted it, so we need to rewrite it. And because this 13 makes the fractions look a little bit odd, I'm first going to multiply every single term with 13. So I'm going to take the 13 out there. It's going to be equal to x minus 14. And now I rewrite it to be in that form. They want the x first, so I'm going to start with x here, the y first, so I'm going to bring the y minus 13y minus 14 is equal to 0. I simply manipulated the equation so that everything is to one side, and that is the form they wanted it in.